Imagine a piece of paper in front of you. Not very big, about the size of a pack of gum. And this piece of paper has black specks on it, like someone shook a pepper shaker on this paper. This is what I saw in 7 brief lessons on physics. Each black speck is a galaxy containing 100 billion suns similar to ours. And a majority of these suns are orbited by planets, like our solar system. So in this universe, there are thousands of billions of planets, such as Earth. And the universe is not just a flat plane like this piece of paper, but a moving, ripping, splashing thing like the sea. Will we ever get to travel to other stars like our sun? This is Fact and Science Fiction. I'm your host, Carly, and this episode is about space travel. This is episode 3 of my 5-episode mini-series on space. And for this episode, I asked my podcast friend Paul for help. Hi Paul, welcome to Fact and Science Fiction.
Hi Carly, thanks for having me.
Of course. Now I want to tell the listeners how I know you, because I think it's so wild. So a long time ago, you had a podcast called Podflix, and I was a big fan of it. When did you actually start that podcast?
I believe we first started that podcast in, I want to say 2009. It was quite a while ago. It was pretty early on in the days of podcasting, I have to say.
I think it was even earlier than that, because I think I was in high school. But so the podcast Podflix was you and your friends watched a Netflix movie every week and then talked about it. And it was during the days of Netflix when they were on discs. Like they hadn't even, or they were just getting their like streaming service off the ground, I think.
Yeah, they definitely did not have streaming when we started. It was all disc-based. It was we didn't really know what we were doing, but we just watched a lot of Netflix and we wanted to talk about it.
Yeah, it was one of the first podcasts I ever listened to, and I was a big fan. And I don't want to age us, but it's been a long time since then. And so we've been Facebook friends and Twitter friends for a really long time. So I just think it's crazy that now you're on my podcast years later.
Yeah, this is great. I feel like things have really come full circle. I'm so happy to be here.
So first I want to talk about how we travel space for real. And then Paul and I are going to discuss science fiction examples. I know Paul is going to talk about Stargate.
Yeah, you really got me sucked back into this world. I had not seen the show in a few years, and I started watching it to get ready for this, and I was like, oh yeah, I really like this show. This show was really great. So I've been watching a lot.
The science hasn't changed much since we first started sending craft to space. Satellites, shuttles, rovers, etc. Rockets and satellites depend on combustion engines. A controlled explosion basically propels these rockets upwards with so much force that it reaches a velocity of 17,500 miles per hour. And then the real rocket science kicks in. The craft has to reach a pretty precise altitude and velocity in order to orbit the Earth like a satellite or fly through orbit to get through the atmosphere and beyond the strongest part of Earth's gravitational pull. Then the fuel and exhaust has to be precise enough that it's efficient. If a rocket runs out of fuel, they can't just go get more. If you've seen Hidden Figures, you know how much math is involved in getting to and surviving in space.
On any given day, I analyze the manometer levels for air displacement, friction, and velocity, and compute over 10,000 calculations by hand. So yes, they let women do some things at NASA, Mr. Johnson. And it's not because we wear skirts. It's because we wear glasses.
Navigating craft in space is tricky too. There's a misconception that there is empty space up there. But it's not empty. Space is full of stuff. It's full of asteroids, debris, gravitational fields, and electromagnetic fields. NASA, as well as organizations like the European Space Center, and now private organizations, are all in the business of exploring space. Paul, what do you think about these private organizations like SpaceX investing a lot of tech and money into space travel?
Well, in general, about I'm glad that private organizations have stepped up where the government has, decided to reprioritize things elsewhere. I wish the government didn't do that. I am someone who, believe it or not, I went to space camp. I went twice. I loved it so much. So I'm a big fan of NASA and everything that they have accomplished over the years. And, I'm sorry that they kind of don't have the funding that they used to, but I am glad that private enterprise has stepped up, and I think it makes for a very exciting time. I know Elon Musk in particular can be somewhat of a problematic figure on various different fronts, but when it comes to his professional endeavors, I am generally a fan. And I think what he's doing with SpaceX is very ambitious and kind of laudable. And I know he's subject to making crazy claims that he has trouble backing up, but the things he's actually accomplished with these various rockets has just been amazing. And it's very interesting to watch, because for a long time all we kind of had was NASA as a blueprint, and they were kind of leading the way, and things were kind of based off of that. And then now these private enterprises are like, well, what if we did something totally different? And it's been very interesting to see completely different approaches, tried, and some succeed and some fail. And I think that aspect of it has been really great. But I would like to see the government get back into it, because I do think it really serves a public good to explore space and to be aware of our planet as a whole and things like that. So I would like in the future to see both work hand in hand, but I've been very chuffed to see these private enterprises pick up the slack.
Yeah, for sure. And I always just bring up Elon Musk because he's like instantly recognizable, but there's a lot of different companies turning their R&D to at least partnering with NASA to do research or trying to take on commercial space flight like Virgin Galactic as well as SpaceX. So I totally agree with you. And I have an example, like NASA is partnering with European governments to do further research in space as well as universities. And so it's not totally out of the game, but yeah, it's the most breaking news is about these private companies kind of doing things that the government would never think of, like putting a car up into space. And then we have people like Elon Musk and these kinds of techno cynics who are like, humans have to leave Earth eventually. Like, we cannot survive it down here. So they're interested in opportunities of like space colonization. I feel like that's the long game.
Yeah, absolutely. And I think that's a smart game, frankly. Like, I tend to agree with these people. Humans like to explore things and conquer, if you will, other places, and the planet's pretty much used up for that. And if we want to keep doing that, we got to look elsewhere. And right now, this is the only planet we have. And if something terrible were to happen here, we got nowhere else to go. And it would be nice to have a backup somewhere else too.
A lot of what I've read is just the idea once we colonize space, just the fact that we will probably never get to go outside again, which is pretty scary. And a lot of the research into making those space flights that can take from months to years, how are human astronauts going to be able to survive psychologically with being in a spacecraft, usually very small, for that long of time? And I think that psychological aspect of space travel is really interesting, and they've been studying it for a really long time.
Yeah, it's going to be interesting to see when they actually start putting people out there for very long periods of time, what the effects are. The people who do that, my hat's off to them, because that's an incredibly brave thing to do, and who knows what's going to happen.
Yeah. I read a release the other day. These researchers are studying teamwork and the kinds of people that would be able to make those missions and what kind of qualities they would have to have. And basically, they'd have to have really great conflict resolution skills. They'd have to be very amiable, a good sense of humor. And it's interesting because like when they first started creating the role of astronaut, and trying to find pilots to fly these spacecraft, they were all like very hotshot Air Force pilots that were very competitive, very ambitious, hotheads. So like they're rethinking that model for sure. So before we take these missions to other planets and across the stars, a really cool project that NASA and the European Space Center is working on is this project called LISA, which is Laser Interface Space Antenna. And they are building it right now, and it's supposed to be ready by the 2030s. And it is 3 spacecraft that will orbit the sun in a triangle, like connected by laser beams. Like they just have like conceptual pictures of what it's going to look like, but it looks crazy. It's the 3 spacecraft together in this triangle will be about the size of the Earth. That's how large and how far away they will be. And what it's going to do is it's basically going to map space. It's going to be able to see farther than any of our telescopes. It's going to be able to triangulate positions. Right now, the release that I read was from Northwestern University that was able to use statistical models to predict what will LISA be able to find. How many like black holes, how many white dwarfs.
Yeah, that sounds like a crazy idea, and yeah, I can't wait to see it if they can actually pull it off. That sounds great.
Yeah, it sounds so awesome. And it's those kinds of projects I think are laying the groundwork for being able to actually travel out there. I didn't know this until just recently, but there's a lot of junk in our orbit right now. Just all the satellites that we've sent out there, they're still up there and they're crashing into each other and creating a lot of debris. And there's this, it's called the Kessler syndrome. That's basically a mathematical equation to like these colliding satellites will just create more and more debris until it's just a cloud around Earth. You know, not only are we going to have to map space, but we're going to have to figure out how to deal with all of that junk up there so that we can get craft out.
Yeah, I can imagine that being a real big problem. I mean, people send stuff up there all the time, and especially now, the cost of space flights has become so cheap that private companies can send these satellites up, microsatellites and things like this all the time. And one thing that I didn't know growing up, but I've learned recently, is if you want to send a satellite up, it has to orbit the Earth in a very narrow band. It can't necessarily orbit the Earth, anywhere around the planet. So there's this very trafficky area that's full of stuff because everybody has to send it to the same area. And yeah, I can imagine that's going to become more problematic as the cost of launching satellites becomes cheaper and cheaper.
So now I want to talk about the theoretical solutions to getting these long distances across space. Physicists have been theorizing about how we'd be able to travel to different galaxies and solar systems, or even to the closest star. So the closest star to our sun is Proxima Centauri, which is 4.24 light years away. So if we traveled at the speed of light, it would take 4 years on Earth to get there. So science fiction movie consultant Kip Thorne explained it like this. If we shrunk down how large this distance is tremendously, our sun and Proxima Centauri are about as far away as New York and Berlin. Now, the farthest any man-made craft has made is that satellite, the Voyager 1. It launched in 1977, and it is only 18-ish light hours away. Kip Thorne wrote in 2014 that in perspective, that Voyager 1 isn't even out of New York yet, let alone close to Berlin. Even traveling 300 kilometers per second, it would take 5,000 years to reach the closest star to our sun. So how do we go faster? One possibility that has been considered since the 1950s is thermonuclear fusion, which is basically harnessing the energy that occurs when heavy hydrogen atoms fuse together to create helium. Basically, we'd use hydrogen bombs to propel ships forward, of course involving shock absorbers and protection.
There, that's it. That's the wormhole.
Say it, don't spread here, huh? It's a sphere. Well, of course it is. What you thought it would just be a hole. No, it's just that all the illustrations I've ever seen, the illustrations. I'll show you how it works.
Sure. So a wormhole is a conceptual theory posed by Einstein and others. That's basically the notion is the shortest distance between two points is not a straight line. If you imagine an apple and you want to get from one side of the apple to the other, the long way is actually to walk around the skin of the apple. A shorter way would be to burrow through the apple as if you were like a worm. And that's actually where the term wormhole comes from. It's the notion of a worm eating through an apple. So the idea is if we could fold space, the actual distance we'd have to travel would become much, much less. And it's a fascinating theory of how to travel. It's highly theoretical, although, it's been great fodder for science fiction. And who knows if it's something that we could ever actually do, but it is, a feast for the imagination to think about.
Yeah, and I want to talk a lot about Interstellar, because Interstellar had wormholes, it had a black hole, and that was really integral to the plot, which... Have you seen Interstellar?
I have, yes.
Yeah. It was really interesting as far as like, oh, this actually feels like there's a lot of science in here. And then towards the end, with the aliens. But it talked a lot about time dilation, which is a major factor as for space travel, at least, from the theoretical perspective. So another example that is used a lot in science fiction is the hyperdrive or light speed, but it basically poses the same idea, which if a ship has the technology to go close to the speed of light or faster than the speed of light, it can go long distances in a very short amount of time. The way that the science of Interstellar posed it is that a ship will have the technology to travel through hyperspace or a fourth dimension to travel at the speed of light or faster than the speed of light. Physicists like even Einstein have contemplated this while figuring out his idea of special relativity. But if the science of Star Wars or Interstellar was as simple as traveling from point A to point B, it would be possible. But these movies are like really rely on linear storytelling, like event A happens, then event B happens. But when you travel at the speed of light, like time dilation effects completely mess that up. So I heard about time dilation in school. I'm sure most people have, but how fast we are going as we orbit the sun determines how much time passes as we do so. So time is relative to speed. So if we go faster and faster, events do not occur at the same speed for us as they do for people who are not at that speed. So for example, if Han Solo flew the Millennium Falcon at light speed to get to Alderaan, there's no way they would have gotten there like too late. But like movies depend on.
Yeah, in a lot of ways, hyperdrive or, hyperspace, whatever, is really the ultimate cheat in storytelling because as you mentioned, time dilation would make it so that any story would have no drama whatsoever. A ship would travel at light speed, and it would take, from the point of view of someone not on the ship, it would take them hundreds or thousands of years to get there. And obviously, at that point, the story is over. So, you very quickly you need some way to get around that ignores all that, and this notion of yes, you can enter another dimension or some weird kind of space something where you can do this is a great cheat. And fortunately, like it would be great if something like this could actually exist, but that seems pretty unlikely to me.
Yeah. We'll find some technology that will allow us to go very fast, but not that fast. Another idea was large lasers, which this was diagrammed in the science of Interstellar, and I thought that looked just wild. But basically, a large laser beam would hit this lens, and then this lens would hit this plate, and the force that would hit it would propel a rocket very, very far, which sounded like something out of Austin Powers.
Yeah, when I was younger, this sounds like an updated version of something that was bandied about, which was called a solar sail, where you would deploy a very large, very thin sail in space, and the light photons from the sun or whatever light source you had, photons of light actually have a small amount of mass, and they would just hit the back of this gigantic sail, and you would very, very slowly build up speed, but you'd get a lot of momentum going, and you could really coast along. And it sounds like concentrating that down into a laser is a way of achieving the same effect, just a lot more quickly, because you don't have to wait for this giant sail to collect these photons, and that's subject to things like tearing from micrometeorites and stuff like that. So this sounds like a much more practical version of that idea, and it's interesting to see these ideas evolve, over, well, I'm not going to say how many years, but let's say a fair number of years since I was a kid, into something that sounds much more plausible now than it did, when I was much younger.
So now we can talk about more specific science fiction examples. So I want to hear about Stargate.
Sure. So Stargate is it was a movie, and then they had a spin-off TV show, which itself had 2 spin-off TV shows, and then prompted 2 movies after that. And it's about a device called the Stargate, which allows you to travel via a wormhole to another location. So an alien race seeded Stargates all over the galaxy, and you can basically dial one from the other, like dialing a phone. And 2 Stargates can make a connection, and you can then step through one and go to the other side. And like all good storytelling, I think, a lot of the drama comes in the constraints that you have. And the constraints in this show are very interesting because one is travel through a Stargate is one way. So the caller can only step through and you can't step back the other way and come back. You would have to turn off the Stargate, turn it back on in the other direction and come back. And then, which means the sending gate needs all the power. And, that gives you a lot of room for drama. Like, you're stuck on the other side. You don't have any power. You gotta come through. And it's a good way for people to travel around the galaxy without a big spaceship and, frankly, very expensive special effects. As the show matured and went on, they actually did develop faster than light travel, which they actually never directly explain it, but it is classic hyperdrive technology where you can travel faster than the speed of light without any time dilation. Although they do deal with time dilation on the show, it is possible for you to open a wormhole near a black hole, and the intense gravity of the black hole it causes time dilation effect on one end of the Stargate, but not on the other. One end of the wormhole, which makes things very interesting because you're talking to somebody on the other side and they're talking back very slowly. They're very drawn out and stuff like that. So they do deal with that, and they actually have one instance of an ancient race was in a war and their ship got damaged and their hyperdrive got damaged and they had to try to make it home. And what they did was they modified their ship to travel as close to the speed of light as possible without entering hyperspace. So these people found them, and they had traveled for many thousands of years. But for them, only a few dozen years had passed on the ship. But they had traveled many thousands of years, and their race had died out, and all these things. And once we contacted with them and told them to slow down, we were able to communicate with them. So the show has a lot of. It takes a basis in fact and kind of extrapolates it out in another direction, which leaves you in kind of a semi-plausible world where you're like, yeah, I could see how that could actually happen, rather than say something like Star Wars, which is more kind of science fantasy than science fiction. This show is set in the modern day, and they kind of take you from a very contemporary environment and slowly introduce new elements to make it more and more fantastical. It was a very interesting show. I actually highly recommend people check it out if they get a chance to. It is, from the 90s, which means a couple things. One, it doesn't look as great as something made now does. But the other thing is, it was from a more optimistic time for science fiction. Now we have shows like Black Mirror and The Expanse and all these gritty, dark, very hard, not hard sci-fi in that sense, but like hard in that like life is hard kind of things. This show was a lot lighter. It didn't take itself super seriously. It had jokes. Like, it wasn't a comedy, but it had jokes and stuff like that. And it was fun. Again, in a very 90s fashion, kind of like a show like The X-Files. It had what would traditionally be known as Monster of the Week episodes, which are standalone episodes. And then it had mythology episodes, which tied into the overarching plot of the season or the show or whatever. So it's very much a product of its time. Personally, I think it's great. I think people should check it out. And if you like sci-fi, it's a great show. I'm actually drinking a glass of water here, which is sitting on a coaster that is a Stargate right now. So I keep it on my desk even today. It's a great show. I'm a big fan. And thank you very much for getting me sucked back into this show.
Yeah, no problem.
I'm going to end up rewatching the whole thing. I can feel it.
Yeah, that's kind of the sci-fi I like. I like The Expanse, but it definitely deals with a lot of heavy themes. And there are some other shows like Altered Carbon and Black Mirror. I can see definitely the draw of like a lighthearted science fiction show.
Yeah, absolutely. I mean, life can be pretty heavy sometimes, and I don't need that in my entertainment at the end of the day, every day. Sometimes totally. You just want to sit back and have and go on a fun romp. And shows like Stargate definitely provide that kind of a thing.
One last example I wanted to talk about is Becky Chambers' book, A Long Way to a Small Angry Planet. I talk about this book a lot just because I love it so much. It's about the crew on a long-haul ship called a Wayfarer, in which they can punch holes through space, basically creating a wormhole to another galaxy and then leaving a bridge behind them. kind of like space highways. And navigation is supremely important in this world because they have to calculate where exactly to place these bridges to make them safe and stable. So that's everything I have here. Thank you, Paul, for coming on the show and talking about space travel. I had no idea you went to space camp. That's so awesome.
It was actually, in retrospect, people make a lot of fun of me for going, but it was an amazing opportunity, and I'm really glad I did it. And I know it's still running, so I would encourage anyone with kids out there to look into it because, you know, it really had a big impact on my life growing up, and honestly can't recommend it highly enough.
Please do a Stargate rewatch podcast.
Yeah, look for my upcoming terrible idea of a Stargate rewatch podcast, which if I end up doing, I am 100% recruiting you to be on the inaugural episode because it's all your fault that I started doing it.
Would totally watch Stargate.
See, there you go.
And you listeners, please rate and review the show on Apple Podcasts or Stitcher. Tell a friend and tag us on Twitter or Facebook at Fact and Sci-Fi. And check out more content on the blog, factandsciencefiction.com. And lastly, thanks for listening.